Welcome to this video on projectiles. Here we've got a cannon. We're firing it at 10 meters per second horizontally. At the same time, we're going to drop another cannonball straight down. Pause the video and decide which you think will land first. Here we go, let's try it. Is that what you predicted? Let's put on some grid lines and we'll repeat that. Each of those grid lines represents the distance that the objects would travel both horizontally and vertically in 1 second. Hello, introduction to projectiles. When we throw or drop an object, it will fall towards the earth. Often it has a curved path. Watch the motion of the parcel being dropped from the helicopter. Observe the motion of the ball being fired from the cannon. Both of these motions are examples of projectiles. Both objects are moving sideways as well as falling. The ball has an upward and downward motion, but the parcel only falls down. The force due to gravity makes an object fall down. With the cannon, the ball is fired upwards, but the acceleration due to gravity is downwards. This causes the size of the upward velocity to decrease to zero at the top of the flight and then increase as it falls downwards. Note that for both objects, their sideways motion is unaffected by the vertical motion. The horizontal velocity does not change. Comparing projectile motion with vertical motion. Suppose an object is dropped vertically at the same time that another object is projected horizontally. Which one will hit the ground first? Let's fire the cannon to find out. Both will hit the ground at the same time. Many people think that it depends on the initial speed of the object with which it's fired, and this is incorrect. A projectile has a vertical motion, which is the same as the motion of an object falling vertically. Both fall due to the force of gravity. The horizontal motion does not affect the time taken for it to reach the ground. Let's try that again, and you can actually now going to increase the horizontal speed, and we'll repeat it. Let's try that again. 25. Try firing the cannons as we've fired the cannons at different speeds to convince yourself of this. In each case, the second ball will be released to fall at the same time. If we click, you can see a multi-frame image of the two balls. Graphs of horizontal and vertical motion. A ball bearing is projected horizontally from the top of a bench. Horizontally, the velocity of the ball remains constant. We will ignore the effects of air resistance. In practice, the air resistance will slightly reduce the horizontal velocity. In the vertical direction, the ball accelerates at 9.8 meters per second. The velocity increases. Notice that we've chosen the downwards direction as positive. When analysing projectile motion, it is useful to consider the horizontal and the vertical motions separately. Projectiles. Example. An arrow is fired horizontally from a bow by an archer standing on the top of a cliff. The initial horizontal velocity of the arrow is 12 meters per second. The arrow reaches the ground after 6 seconds. Part A. How far out from the base of the cliff does the arrow land? That's another way of asking what's the range of the arrow. B. Draw a velocity time graph of the horizontal velocity for the 6 seconds. C. Determine the vertical velocity of the arrow just before it strikes the ground. D. Draw a velocity time graph of the vertical velocity for the 6 seconds. And E. Using the area under the graph, determine the height of the cliff. In projectile problems, we must be careful to keep separate the horizontal information and the vertical information. Each part of the question will relate to either the horizontal or the vertical motion, with the time being the only constant factor. Pause the video and try this example yourself. Horizontally, we know that the velocity is constant. So we have a velocity of 12 meters per second and a time of 6 seconds. So taking the formula S equals V times T, displacement equals velocity times time, and placing the numbers in, S equals V times T, S equals 12 times 6, we can see that horizontally the arrow travels 72 meters. We know that the velocity horizontally is constant, so a velocity time graph would have a straight horizontal line with the horizontal velocity as 12 meters per second. It will travel like this for 6 seconds. Vertically, there's an acceleration. In this example, we take the acceleration due to gravity as 10 meters per second squared. As you know, for National 5, we take the acceleration due to gravity as 9.8 meters per second squared. So I'm hoping that you will adjust your results accordingly. We use the equation acceleration equals v minus u over t. But in this case, it helps us to reorganize that equation. So we rearrange it to give us v equals u plus at. We can then simplify it because u is 0. Although horizontally the arrow is travelling at 12 meters per second, unlike here where it says 12 meters per second squared, I've just seen it's 12 meters per second, vertically there is no initial vertical velocity, so u will be 0. That gives us a simplified equation of v equals u plus at, or 0, which really should be obviously 9.8 times 6, which is approximately 60 meters per second. We could plot that on a velocity time graph, where we take at 6 seconds, we know that the final velocity vertically. So we could plot that graph. Again, this is taking g as 10 meters per second. When we do that, we can then find the area under the graph to find the height, because the area under the graph is displacement. So the area under this graph gives us the vertical distance that arrow has fallen. So in this case, displacement, or the height of the cliff, or the height from which the arrow was released, is the area under the graph, which is half times 6 times 60. Half of 6 is 3 times 60, 180 meters. So the arrow is released 180 meters above where it lands. This is the structure for completing all the projectile motion questions. Now let's try Newton's thought experiment. Newton's thought experiment. So Isaac Newton imagined an experiment in which an object could be fired into orbit around the Earth. His understanding of projectile motion allowed him to work out how this might be possible using a large cannon. You must remember that Newton did this in the 1680s, about 1687, when he published his results. At that time, there'd been a Great Fire of London about 20 years ago, and a massive bubonic plague. Wars were fought with cannons. Newton's argument went like this. Imagine a large cannon could be fired with an object horizontally many miles. The projectile would have a constant horizontal velocity and a uniform vertical acceleration. The uniform vertical acceleration being the acceleration due to gravity. Let's have a look what this does. So you can see that that travels a great distance because it's got a large horizontal velocity. Now, imagine a larger cannon capable of firing the object beyond the horizon. The projectile travels so far that we have to take the curvature of the Earth into account to measure how far it travels. Here we can see that had the Earth been flat, it would have landed about here. Instead, it goes that extra distance because of the curvature of the Earth. Now imagine a cannon so huge that it fires an object with such a large horizontal velocity that it falls at the same rate of the curvature as the Earth. Here, the projectile never hits the ground. The object circles the Earth in orbit. The object remains in orbit because it is pulled by the Earth by gravity, not because it has escaped gravity. This is how satellites remain in orbit, just as it did in the previous version. Let's just show that again. Interactive summary. Why don't you pause here and try the answers for yourself, and then come and check them against what I've done. Let's hope I can get all 5 correct. Ignoring air resistance, for a projectile, the horizontal velocity remains constant. When an object is projected, there is acceleration due to gravity in the vertical direction. The horizontal and vertical motions can be treated independently. An object is dropped vertically at the same time as the object is projected horizontally. They will hit the ground at the same time. A satellite remains in orbit because it is being pulled to the Earth by gravity, not because it has escaped gravity. I hope you got all 5 correct.